We have a ball that has a mass of 0.025 kilograms on the end of a 0.6 meter long string. It'll complete 10 vertical revolutions in 6 seconds. It is a vertical circle, so we're going to have to worry about gravity. So when we're at the bottom, I guess gravity will be going down and tension will be going up. Let's go ahead and write our known off to the side in the margin there. So mass is 0.025, radius is 0.6 meters, and then for period, we have 6 revolutions per 10 seconds, so 6 divided by 10 would be 0.6 seconds. We're looking for the tension, and it's going to be tension is up when force of gravity is down, so our centripetal force will be coming from tension, but it'll be tension minus mg because it is the net force that is your centripetal force. So our free body diagram, we've got tension up, mg down. There are no forces horizontally. Vertically, we've got tension minus mg. Tension has to be bigger than mg for the net force to be towards the center of the circle. And of course, net force is equal to mass times centripetal acceleration for objects moving in circular motion. We want to solve for tension, so we're just going to add mg to the other side. So Ft is equal to MAC plus mg. We don't have an acceleration, but we do have radius and period, so we're just going to convert acceleration to 4 pi square r over t squared. Because we know acceleration is v squared over r, we're going to square velocity. Velocity is 2 pi square r over t. I'm sorry, it's 2 pi r over t. Then we square it, divided by r, we're left with 4 pi square r over t squared. When we plug in our numbers, we would have 0.025, 4 pi square times 0.6 divided by 0.6 squared plus the mass 0.025 times g, gravity, 10. When we do that, we calculate it all the way across, and we get 1.895 newtons for the tension. Now at the top, it's going to be a little bit differently, or it's going to be a little bit different because force of tension is down and so is mg. Both your forces are down, so you will be adding those two forces for your summation of forces. Again, nothing in the x. Tension plus mg in the y is equal to MAC. Solving for tension, we're going to subtract mg to the other side. Force of tension is equal to MAC minus mg. Again, we have the radius, we have the period, we don't have velocity or acceleration. So we're going to break acceleration into 4 pi square r over period squared. And again, this comes from velocity being 2 pi r over t. Acceleration is 2 pi r over t, all of that squared divided by a radius, leaving us with 4 pi square r divided by period squared. Put in our numbers, put it in the calculator, we get 1.395 newtons. What is the minimum velocity the ball can travel to make it around the circle? We do the minimum velocity at the top. That is the place that we do the minimum velocity. So our free body diagram will have mg going down. We would have force of tension going down, but we're going to make that force of tension the minimal, the smallest number you can think of. Negative is not small, it's just the opposite direction. So we're going to make it 0. 0 is the smallest number, leaving us just with mg keeping us in the circle. Our summation of forces in the y would be mg is equal to MAC, since tension is 0. We're going to solve for velocity. Rewrite our equation. Masses cancel out. Acceleration can be rewritten as v squared over r. We are looking for velocity, so we want the v. Multiply the r to the other side, you get rg is equal to v squared. Square root both sides, you get the square root of rg is velocity. So now we've solved for velocity. The square root of rg will always be your minimum speed equation. 60 kilogram passenger on a roller coaster with a loop radius of 20 meters travels 21 meters per second through the loop. So we've got mass of 60, we have a radius of 20, we have a velocity of 21. How much normal force does the passenger experience at the bottom and at the top? So we're going to do top and bottom for this passenger, and we're looking for force normal. So just like what we were doing in class and previously where it was force tension, just take the force tension out, pop in the force normal. It's going to be a force that can work as a centripetal force plus or minus gravity for any one of these. So don't let it mess you up. just exchange force tension for force normal. At the top, they're both going down. At the bottom, normal is up and gravity's down. Of course, normal will be more than gravity at the bottom, so that way the net force is still towards the center. I'm just separating these out for top and bottom. I've got my free body diagrams on the left, and then I'm just doing left and right. So top, I'm going to say I've got force normal plus mg is equal to MAC. And AC, of course, is V squared over R. And at the bottom, going to be very similar, but force normal minus mg, because mg is not going the same direction as normal, it's going the opposite, is equal to MAC, and of course, AC is V squared over R. We went ahead and put in terms of V because that's the information we have over on the left side. We have V and we have R, so just put in those terms. Plug in the numbers we know. Mg would be mass times 10 is equal to mass of 60 times velocity, which is 21. We're going to square that and then divide by radius of 20. On the other side, identical, but instead of adding 600 on the left side, we're going to subtract 600 on the left side. When I put this in my calculator, I kind of work it backwards, I think, but I did 21 squared divided by 20, and then I multiplied by 60, and then for the top, I subtract 600 over, and on the right, I did almost the same thing, 21 squared divided by 20, and then I multiplied that by 60, and then I added 600 to the other side. For the top, I get a force normal of 723. And on the bottom, it's going to be, should be a difference of like 1200. Yeah, force normal would be 1923 newtons. How many G's does the writer experience at the bottom? So the writer's experience of G's all comes from the force normal. If you've got no G's, then your perception is you'd feel weightless. So it's all based on your force normal. So your force normal, though, is a force, so we've got to divide it by the mass to get an acceleration. 723 divided by 60 is going to give us an acceleration of 12.05. A g is 10, so how many 10s are there? We'll divide by 10, and you get 1.205 g's. At the bottom, same thing, 1923 divided by 60, so that we're going from a force to an acceleration by dividing the mass. Force divided by mass is acceleration. We get an acceleration of 32.05. Divide that by 10 to see how many g's there are. 3.205 g's. What is the minimum safe velocity for this roller coaster? We know the minimum safe velocity would be based off of square root of rg. We've derived it already, but let's just go ahead and use it again. Square root of rg would be the square root of the radius 20 times g 10, or the square root of 200. Square root of 200 looks like it's going to be 14.142 meters per second. Last question, a 60 kilogram driver. So we've got mass of 60 kilograms, radius 25 meters. How fast, so we're looking for the velocity to become weightless. Now weightless, we know force normal is 0. And for a driver in a car, the force normal is what's kind of pushing up. We got gravity down. We know force normal would be what would cause the driver to be in circular motion. Now, when he comes up and over a hill, force normal would be pushing up, gravity down, because he doesn't go inverted on the hill. A roller coaster, yes, but when you're in a car and you kind of get to the top of a hill, your seat is pushing up on you, gravity's pulling down. Force normal is going to be 0 because he's feeling weightless. It's kind of like when you go over a bump in an intersection really fast and your car kind of jumps through it. Not that you would ever drive like that, but maybe your parents are a little aggressive. Anyway, so instead of saying force normal or mg minus force normal, because of course it should be directed down to the center, force normal is 0, we're left with mg is equal to mac. Looks like we just simply derived the velocity is square root rg, right? Well, it just shows where it comes from. Totally fine. So the velocity is equal to square root, the radius is 25, g is 10, so the square root of 250. And what is that square root of 250? Should be more than 14, right? 15.811 meters per second.